interact with Usha Rengaraju. Usha is a triple Kaggle grandmaster. We will share her LinkedIn profile with you, but I just want to brush up actually. So she is chief data scientist, and she's uh, uh, in women in AI, and then she's a corporate trainer, and then she's also an autism advocate. She specializes in a lot of Python, deep learning, computer vision, machine learning, and has been doing, she's a freelancer also, has been doing many projects around this to a lot of corporates. So today she's here to talk to us about JAX. So let us listen actually what this is, how it will help us, and how you can use it. Also, I would recommend before the session starts as to put your questions together, because we have made this session more uh, in such a format wherein it is more interactive, and it will be better and useful to all of you if you can use this opportunity to put your questions out there about something as simple as what are my first steps, or I mean, I have shared that. Hi Usha, I see that you have joined. Thank you.
Yeah, hi.
Hello. So I have shared with her that our community is mostly students and young professionals with 2 to 3 years experience in this domain. So I know that there are a lot of questions in your mind as to how to go about data science, or how to leverage machine learning for your career, how to use it uh, to switch careers if you're not in that right now, and what kind of projects to take, how to choose projects, how to update your resume or position your resume so that you get opportunities around, or some projects or internships around it. So bring out all your questions that you have. I request all of you after the session or during the session, if you have questions, feel free to use the chat. And after, once the Q&A is, then maybe you can raise your hands and you can ask around. So I hope you make use of this opportunity of talking to Usha and leveraging her expertise. Over to you, Usha.
Yeah, hi, hello everyone, and thank you so much, Usha, for the introduction. It's my pleasure to be part of the session hosted by you and the GDG Visac team. And thank you so much, everyone, for joining on this, Friday working day of 2022. And thank you so much for joining. This is going to be a very different session because it's more of a research. uh, it'll be easy to follow you, so you don't have to. 1 minute, let me just share my screen. So you don't have to worry machine learning prior experience and all that. It will be easy to follow as long as you Python or some programming language earlier. You'll be able to follow it. So we are not going to learn anything machine learning as such. We are just going to learn about a new library and how it can be used. So any programming background, prior programming background should work as a prerequisite. If you know NumPy already, then that should be great. And so once again, before I start the session, I would like to thank Usha and her team, GDG Visac team, for organizing a great DevFest Visac last month, and again putting together this event as a part of ML at DevFest track. So organizing an event is not an easy thing. It takes a lot of effort. Personally, I'm an organizer for GDG myself, so I know it takes really a lot of effort. So, and doing it dedicatedly year after year over a long period of time really requires a lot of passion for the. So I really appreciate the work of Usha and her team. Keep doing great work. And with this, let's get started with the topic. So this JAX is nothing but it's a library from Google's DeepMind. And DeepMind is a research wing of Google. If you're not already aware of it, DeepMind has got a big office in London. It has its headquartered at London. So this is a research library which has come out from DeepMind. So Google also has another machine learning framework. If you're not familiar with machine learning, this is just a background for you, called TensorFlow. So most of you will be familiar with TensorFlow. So both are coming from, but JAX is a bit more powerful compared to TensorFlow. TensorFlow is good if you're just doing an ordinary workflow, an ordinary experiment. TensorFlow is great. You can just stop with TensorFlow. But if you want speed, if you want to be very, very fast, then JAX. Again, JAX is a very new library, so there are not many support for third-party libraries. It's a very pretty much used only in the research labs. For example, Google Research uses a lot of JAX. Internally, Google's many of the Google applications are powered by JAX. Internally, Google Research team uses JAX, and you see other research library labs across the country. Microsoft Research or OpenAI. There are many research labs which uses JAX, but outside the research labs, there is very less adoption in the industry and all. So this is predominantly, at this point of time, it is only used by research labs. Maybe in future, when many people start realizing the power of JAX, they'll start using in the industry. And so it is very powerful, 15 to 20 times faster than TensorFlow. So the whole session is going to be like uncovering why JAX is so powerful, what are the features of JAX which makes it so powerful and which gives it this kind of a power that it's 15 to 20 times faster than the existing frameworks like TensorFlow, PyTorch, is what we are going to see now. And why should we even consider looking at this framework when we already have well-established frameworks like TensorFlow and PyTorch? See, if you take PyTorch and TensorFlow ecosystem, Keras also, these are frameworks which has been there for a really long time and they're very well established. Most of the companies adopt either TensorFlow or PyTorch as their code base. They're well established. Even machine learning on production is really good, and then machine learning on cloud, everything works really good with these frameworks. And so this whole session will uncover why you should even consider going for JAX when there are well-established frameworks like TensorFlow, PyTorch. So it will be like mostly the features of JAX and the what are the features which gives it the power. We're going to discuss this in the next 40 minutes. So this is what will be the topic. So what is JAX in the first place? And what are the features of JAX? If you take any programming language, there will be building blocks of the programming language, right? Even English language, you take ABCs, alphabets are the building blocks of English language. Same way, programming languages also have building blocks. So we'll be learning the building blocks of JAX. And then we see JAX is again a, won't be able to cover all of it in a beginner level session. So we'll be covering some important features at the high level, like what are these features? And that is at the high level, we'll be covering some 4 to 5 important features. And so these feature, especially starting from 6th to 9th, requires a little bit understanding of machine learning. If you understand, you can grasp it better, but it's not mandatory, the point 6 to 9 alone. And finally, 10. If you take JAX, it is just trying to mimic NumPy. So, what is it? But NumPy and JAX differs hugely in one area. Most of the time, JAX is just trying to mimic the NumPy library, but in one area it is differing very hugely. That area is random number generation. So, we'll also be discussing about this random number generation, like how JAX way of generating random numbers is so different from NumPy way of generating random numbers. So this is what is going to be the agenda for today's session. This is what we are going to cover. So JAX is a Python library. So JAX is most of you would have programmed in Python. If you are interested in data science, or if you want to, you would have the first preferred language for data science is Python. And so you might have worked in Python libraries like NumPy, Pandas, Matplotlib for visualization, and all these libraries you would have explored. So JAX is also a Python library. And this is predominantly built with research in mind. So it's a high performance machine learning research library, which is built in Python. And see, JAX, when you start working in JAX, you will not just JAX, if you see, you won't feel like you're learning something. So it is similar to NumPy. NumPy is the first library you would get when you start your data science skill. Most of the things you will not feel like you're learning something totally new programming language. Kind of a feeling you'll not. Very, very simple. Very easy, since you are learning something similar to something which you already know. You'll find it easier and you'll not feel like you're learning totally out of the world. It's a very similar programming language. Some of the features of JAX which we will here, Raj, there are compilation. If you have learned any programming language, you will be knowing about compilation, interpretation, right? More just the code which you write will be compiled code. So after every program, you will first do compilation. Compilation convert your high-level programming language. Every time you want to run the program, assembly code is what the machine level instruction. This is what is compilation. But compilation is one type of compilation technique. So this whole compilation happens dynamically at runtime, and just-in-time compilation has got a lot of benefits. This is not restricted to just-in-time compilation. Is the compilation concept as it's not only JAX is doing just-in-time compilation. This is Java uses just-in-time compilation. Java C compiler uses just-in-time compilation. There are many compilers which uses just-in-time compilation. So JAX also uses just-in-time compilation. One is that the Google ecosystem is also using just-in-time compilation. One thing which you need to understand is I cannot work that well with accelerate. NumPy on GPU and TPU is you'll have to a lot of boilerplate connect with GPUs, and if you want it, but this JAX works really well with GPUs and TPUs, so you don't have to write that much of a junk to connect with accelerator. So TPU is tensor processing unit. Heard of TPUs before? I'll just show you TPUs in a Google code. So I'll just take this Colab notebook. Just in case if you've never heard of TPUs, and if you just go to Google Colab, as long as you have a Google account, you should be able to have Google Colab. And you have TPU and GPU. So TPU is tensor processing unit. It's an accelerator, and this is TPU is much faster than GPU. It is like certain certain models like ResNet faster than GPU if you're using TPU to train it. So TPU is basically an accelerator. And TPU is not, you cannot buy TPU in shops. Unlike you can buy GPUs from retail outlets, not buy TPUs from retail outlets. TPU can be consumed only if you are using Google Cloud or Google ecosystem of products like Google Colab and things like that, or Kaggle. You can only consume TPU if you are using Google ecosystem of products, either Google Cloud or Colab or Kaggle. So TPU is proprietary to Google, and NumPy cannot work that effectively with accelerators like GPU and TPUs. But JAX can work really well with these accelerators, especially JAX plus TPU combination is too good. It's unbeatable. JAX alone itself is powerful, but JAX plus TPU is too powerful. So this is what gives the power which JAX has. Then there are certain concepts. See, it's not necessary you should to understand automatic differentiation. If you have worked in machine learning, it is great. You'll understand this concept better. But even if you have not worked in machine learning, you understand. I think everyone who's attending this class must have completed 12th standard. At least you should have completed 12th standard. So in your 11th standard mathematics, you should have learned differentiation or some. I'm not sure of the current syllabus if you're learning it 9th standard or 11th standard. Most of you would have learned differentiation, differential calculus. You should have learned, right? Taking differentiation of a function is something which if you know machine learning, you'll understand in machine learning we have to take derivative. And but even if you would have learned in 11th standard calculus, right? You take derivative of a function, derivatives, or all these concepts. So in machine learning also, where of a function. Of a function, there are many open source libraries. JAX way of taking derivative. So to take a derivative techniques, differentiation techniques, we have something called differentiation, numerical differentiation. Many techniques are there, but in machine learning, particularly the only technique for taking derivative of, and that is to do what in machine learning there are separate own way of doing differentiation. PyTorch has its own way of, each and every framework has its own way of doing. Doing what is very, very powerful. So if you know machine learning, you'll be able to understand what automatic differentiation is. Even if you do not know machine learning, automatic differentiation is nothing but you're trying to take the machine of a function. And that is made very, very easier in JAX. And there's also another concept called automatic vectorization. We'll be covering automatic vectorization with examples, which will help you understand the concepts better. But for converting all the scalar level implementation in your code into vector, but I'll show you some example to understand this concept much better later. And so then composing multiple transformations is big. By composing multiple transformations and the random number generation, very, very effective in JAX. NumPy also does random number generation, but JAX uses a different algorithm, 100 numbers. Very efficient. All these features detailed in the upcoming session. Only a teaser now for sharing these are the features of JAX which make. But we'll be going taking each of these and we show. So we'll go to we'll get started now. We have about the JAX, about the features. These are about the features. Let's start with the basic building block. Any programming language will have a base. The NumPy library, the whole numerical computing. The whole of NumPy library is based on something called NumPy array. The entire NumPy library is built on ND array. So this the JAX also has a block. That building block is called device array. So it is the core object in. So how to create a device array? To create a device, you have to import the packages. In NumPy, if you want to create an array of 10 zeros, you will just call n dot zeros. In calling it as jnp dot zeros. So you take anything like all the NumPy functions. I'll just show you. If you take JAX package, you have a function for every NumPy function out there. See, every NumPy function out there, you have a wrapper function in JAX. This you just take so if you take the API of JAX, there are so many functions here. So for every function in NumPy, there is a corresponding wrapper function JAX. So you ABS, you have a numpy.abs also. First, you can just go and see numpy.abs. So the numpy.abs. So numpy.absolute. So the wrapper function and the shortcut is nb.abs. So you have absolute value of a function, you've got np.aws in num. The corresponding function jnp.aws in JAX. So for every function in NumPy, you have most of the functions in NumPy, you have corresponding wrapper functions in JAX. And for SkyPy also, SkyPy is another library used for scientific computation. For most of the library functions in SkyPy, you have a corresponding wrapper function in JAX as well. If you take jax.skypy, you have for every SkyPy function, you have a corresponding implementation of the JAX functions here. So you can take any functions here. Like for example, I'll take egg. You can find the SkyPy method. You can method. So you a library for Python library for. So if you take SkyPy, you have something module. You have something called egg. This is used for vectors. The same also available in JAX. So NumPy are the basic computational for doing a lot of computations in Python. And in JAX, for every function, you have most of the functions, not every. You have a JAX wrapper, corresponding JAX. So here, so if you create an array in NumPy, what you will do is you will import as np and zeros of 10 you will write. In that in JAX you are writing import jax.num, because every function in NumPy has a wrapper JAX. So I'm importing jax.numpy package as JNP. You can give any alias you like. JNP.0. I'll be able to create an array of 10 numbers, 10 zeros. So the base building blocks of JAX is array. In NumPy, numpy.nd array, that is the fundamental building block of NumPy. JAX fundamental building block is device array. Whatever you want to do in NumPy array, you array. So for example, you can do NumPy arrays. So I'm generating some random numbers to JAX. I have to do mp.random.random numbers in NumPy. I can take in NumPy, convert it into JAX. So I've taken this random numbers in NumPy, converted it into JAX. Now I can do a dot product. So dot product, you'll use a lot of dot products in data. So to do a dot product, we have a method called dot in NumPy. Similar method is available in JAX as well, JNP dot. So dot product using NumPy array. Here I'm doing a dot product use JAX. This is whatever you you are doing in NumPy. Most of it you will be able to JAX as well. JAX has corresponding wrapper function, functions, and SkyPy functions. If you see this code, here I'm actually using timer to compute how much time it took for doing dot product using NumPy array and how much time it took to do a dot product using a JAX array. This is what I'm doing. Here, if you notice, there is one line called block until ready. What is ready and why even put it? You have to understand one thing. JAX has got asynchronous dispatch, which means if you are telling np dot, JAX will not immediately do computation np dot. It will in the scheduler. Whenever it is free, it will compute that. It will immediately compute it. So that is what is meant by asynchronous. It's not synchronous execution. JAX has asynchronous way of execution, which means whenever it is free, the compiler or interpreter is free, it will execute it. It will not execute immediately. What if execution time you want it to execute immediately? And if you want it immediately, then you have to explicitly block until ready. You have to mention it because JAX has asynchronous way of execution. So if you just type any command, it's not necessary it will execute it immediately. So if you want it to execute immediately, then you will have to go block until ready. Here we have seen the basic building blocks of JAX. We have created the array of 10 zeros, and then we are creating, or we are trying dot. We used to do in NumPy array using dot function. We are using dot product using the JAX device array. And one important concept we learned here is JAX has got asynchronous way of execution, because if you're trying to give it some command, it will not immediately execute. It may immediately execute or it may not. But if you want to compute the execution time, you want it to execute immediately. In that case, you have to explicitly mention block until ready. JAX has asynchronous way of execution. So this is one important point up to here. One more thing which you need about JAX is immutable. Immutable means you cannot do in-place array updation. So if this jnp.0, if I'm trying to update the same, it will work. It will not throw any error. But the same code in JAX will not go. What I'm trying to do is I'm trying to create an array of 3x3 matrix, 3x3 matrix of zeros. And in the first row, I'm trying to update it as 1. This is what this code is trying. This code is trying to create a 3x3 array of zeros, and the first row is trying to update it as 1. Not work in JAX, but this will work. It will work in NumPy because NumPy arrays are mutable, but immutable means you cannot change, and so you cannot this code this. But what if you want to update it? To update it, you can use an attribute set to update, but you can store it in a new variable. You cannot do an in. If you want to update an array, you can do an updation and store it in a new array object. You can in place updation in JAX. So JAX is immutable. So here I'm trying to create a 3x3 array of 0. Update the first row as 1. This is in NumPy because now immutable. JAX arrays are immutable, which means I cannot in place updation. So here in this, but what if in data science a lot of times we want to do an in-place updations, we want to do array updations. So if at all in JAX, if you want array updations, the add and set attribute, you can update the array and store it in a new array object, but you cannot do an in-place array updation. JAX arrays are immutable. So that is one of the more JAX. So there are other important concepts as well. So JAX operates pure functions. So what is pure? It is for any function if you give a certain same output. So some of the cos theta is a pure function. Cos 0 is always going to give me the same. Every time I give cos 90, it will always give me the same value. Every sin theta is also a pure function. Every time I give sin 0, it will give the same value. Every time I give sin 90, it will give value 1. Pure functions are functions which does not have side effects. And every time you get the same output, it will always give the same input, you will always get the same output. So functions which does not have side effects. Example, cos function. So why do we even bother with pure functions? The very powerful, very practical pure functions as possible in your code. The reason is that you use pure functions, and parallelization is also very easy when you use pure functions. So for these reasons, pure functions are very powerful. And JAX works really well with pure functions. So we have seen what is pure function. So what is functions which does not have side effects, and for every value of it, always get the same output. The reason why we go for pure functions are realization is very easy and reproducibility is also very easy. And JAX works really well with pure functions. And so pure function, you can write impure functions in JAX, that is functions with side effects. The problem is JAX won't give you guarantee that it will work properly. It will stand without errors when you use pure functions, but no guarantee that your function code will always behave the same way every time you execute it. JAX will not give you a guarantee if you use impure. JAX is not saying you shouldn't use. You can use, but I won't guarantee every time you run it and this is the way I'll work. That is what JAX says. JAX generally recommends pure functions. And so the important concepts up to till now is JAX arrays are immutable, and does not encourage you to write impure functions. JAX prefers functions which are pure. So these are, up to now we have learned what is JAX. Some of the features of JAX we saw at the, and then we started with the building blocks of JAX, which is called device array. And we have seen how JAX is trying to mimic the NumPy array. And for every function, most of the functions in NumPy and Sky have a corresponding wrapper function in JAX as well. So we have seen all of this till now. Next, we are going to see 4 to 5 important features of JAX, which gives it the. So why 20 times faster than TensorFlow, PyTorch, and the other machine learning frameworks out there? We are going to see that now. The first concept is automatic differentiation. So in machine learning, we have a situation to take a derivative of a function. We have to take derivative of a function to update. Machine learning, we have some weights and parameters. Every layer will have weights and parameters. These are parameters of the model. To update the parameters of the model, you have to take the derivative of a function. So this is one important step in the machine learning process. So this particular place where of a function in machine learning, in the this concept called automatic differentiation. Derivative of function using several techniques. You differentiation, or you can use numerical differentiation, symbolic differentiation as well. Both and symbolic differentiation has got some. So automatic differentiation is what is take the derivative of a function. If you know, but if you do not know machine learning also, I'm sure derivatives and all that, everyone here is completed 11th standard, I think. And you would have learned differential calculus where you are taking derivative of a function and all. Machine learning knowledge is not mandatory for this session. Understand machine learning, it's great if you do not know also. Standard, you know, you understand, right? You would have taken derivative of a. So machine learning generally uses automatic technique for taking a derivative of a function. And if you do this automatic differentiation technique, most of the frameworks in data science, Flow, PyTorch as their own library or own functions for taking automatic differentiation. But JAX way of taking automatic differentiation is very, very powerful. Separate outside these frameworks, there are separate open source library like AutoGrad and all that. But JAX is the most. So if you want to take any function in your, it should be a data science function. You take any programming languages, you will write functions, right? Function. Any programming language, functions are building blocks, units of a program. I've written a function. Similarly, here I have people who know data science. Softmax is an active with it. So I have one function here which is called softmax, and I want to take a derivative of this function. How to do this? If you want to do this in JAX, it's very easy. This gives you something called grad. That function, I take easily the derivative function. So grad is a transform which is available, which lets you take derivative of any function. So grad max, I'll be able to take derivative of softmax. It's not necessary you always use softmax. You can put there to take a derivative of a function. JAX as a transformation called grad. So another big advantage of it is there are many other advantage. You have something called value. You can take compute the value of the function. You can also you'll all be able to get both derivative, both the value of the function, the separate attributes which will let you do. So it differentiation in machine learning. We have certain places we want to compute the vector, certain places we have to compute the Jacobian vector. Certain places there are different mathematical operations with related to differentiation we want to perform. For all mathematical operations as a corresponding function to do that very easy. Just like this, it has another function, VJP, for taking the reverse differentiation. There are many other differentiation methods which JAX exposes. So you can go and check out the API documentation to understand what are the differentiation related functions which JAX is exposing. And one more thing is, if you get higher order derivative, JAX makes it very easy. If I want to calculate the fourth order derivative, then I can put JAX of grad of grad of grad of grad. I'll be able to calculate the fourth order derivative. So you can compose multiple transformations and you can compute the higher order derivatives very easily. There are many advantages of grad compared to its counterparts in TensorFlow and in PyTorch. You write a lot of code if you want to compute the higher order derivatives, but in JAX it's going to be very, very easy. So now let's see performing with regards to the other framework. So the last column is the JAX. So with regards to AutoGrad and TensorFlow, JAX and PyTorch are the way of taking automatic differentiation are performing better. This is for of 1024. If you want to increase the batch size, still PyTorch and JAX is performing better than AutoGrad and TensorFlow libraries. So this is the first feature of the second, just-in-time compilation technique. So we have already seen what is just-in-time compilation technique. It's just a compilation technique which happens dynamically at the runtime. There are many advantages of doing just-in-time compilation. You consume less memory. You can do a lot of code optimizations on the fly. So just-in-time compilation is generally preferred by many of the programming frameworks. Java also uses just-in-time compilation. There are many other programming frameworks which uses just-in-time compilation. So in Google, TensorFlow and JAX uses just do the just-in-time compilation. You own compiler called XLA, accelerated linear algebra. It's a ecosystem. What it does is compilation. It takes all your high level of TensorFlow or high level operations written in into machine level instructions as the just-in-time compilation. To do just-in-time ecosystem has got something called accelerate, which takes all your high level operations and breaks it down into machine level instructions. So doing just-in-time compilation has got some performance benefits. This particular statistic shows you have got great performance benefits if you use just-in-time compilation in comparison with the code which does not just-in-time compilation. I'll show you small. So the same softmax 6 function which I showed you as an example in the earlier slide. I'm going to do just-in-time compilation in JAX. You have to use a transformation called JIT. Do a just-in-time compilation of softmax, JIT of softmax. You write if you want to do just-in-time compilation for that function, you just do just a JIT of that function. So now, if I want to compute the time with JIT, so first thing is I'll do is with JIT, and the second thing is with JIT. It took me 13.9 milliseconds. It is taking me 7.9, 50 times performance improvement. Time comparisons, it gives you great. So here I'm with simple function, I'm able to boost. So to do just-in-time compilation in JAX, the transformation which it exposes is JIT. And the concept which gives JAX its power is automatic vectorization. So JAX makes automatic vectorization very easy. But before vectorization, what is this whole vectorization all about? So vectorization, you take any scalar implementation in your code and you put it into vector. So if you take one of the scalar implementation is having a lot of for loops, you take all these convert it into vector implementation. That is, you're eliminating for loops because it's a very inefficient way of coding. So why do you use vectorization? The reason why we do vectorization is because it's an efficient way of writing code. It's also very, very easy to debug. You take for loops, it's really, really long time to debug, especially your 1,000 loops or 2,000 loops. Imagine how long it takes. So doing vectorization gives you more power, efficient way of writing code, and it's also very, very easier to debug. So machine learning is great. If you do not know machine learning, you'll be able to understand. So what is this? That's an hypothesis function of a linear regression. So, but you do not know machine learning also, don't worry. You take as some function, the if I have to code this function in Python, and if I have to write the same function in unvectorized way, on my left hand side. But I take the same function, and if I have to write it in a vectorized format, I can use a dot product. This is what is unvectorized implementation, which is using for loop, and this is vectorized implementation without using for loop. Now I unvectorized and vectorized implementation. So if you take unvectorized implementation, it takes 6.46 milliseconds, and vectorized implementation takes 18.8 microseconds. So vectorized implementation gives you power. If you see the kind of performance, it's really. But even in TensorFlow, even in PyTorch also, vectorization is done, but you do it manually. So you can take torch.mm, which is for matrix multiplication, BMMs for batch matrix multiplication, which is a vectorized way of doing it. So you have to write manual code if you want to do vectorization. But JAX makes this whole process easier by doing automatic vectorization, and it gives you a transformation called VMAP. Whenever you want to take a and you want to vector, you can just use a VMAP transformation, pass the function name as the parameter, and you'll be able to automatically vectorize any function. So automatic vectorization is made easier. Imagine if you have to take a huge piece of code and convert it manually into a vectorized form, that's a lot of pain. JAX made by exposing a transformation where you can easily vectorize any as a parameter to VMAP. Vectorization using VMAP. So we have seen the final feature, one feature of JAX, which is using PMAP. So a machine, we try to do as much parallelization. The reason why we go for parallelization things at a very short period of time. So that is why we have multiple GPUs. The reason is if you have single GPU, if it is going to 2 days to do a thing, if you use 2 GPUs, you will be able to do the same thing in a single day. That is the time, is the important factor why people go for multiple devices. So using multiple devices, and if you want to achieve parallelization, you can do it very easily in JAX using the transformation called PMAP. So PMAP is a transformation in JAX. Whenever you want to do device parallelization, that is, you want to break down and execute it parallelly at multiple devices, then you can go for PMAP. So PMAP transformation in JAX, which lets you do the device parallelization. Where CPU, TPU is enabled. 8 cores. So if you have to take a single job and execute it parallelly across these 8 cores, code is what is given in the slide. So we have come to the today's session, which is called pseudo using PRNG. I told you in the beginning that random number different in NumPy compared to random number JAX. If you take random number generation in NumPy, it uses something called Mersenne twister. This Mersenne twister algorithm is what is many of the scenes in random number generation in NumPy. It's a efficient way random numbers. It's actually dependent on the previous state. If you want to generate a new random number, it is actually dependent on the previous state. It will apply a transformation function on the state, and then it will be able to generate a new random. A dependency on the state. So, which is not a very way, which is not JAX as the philosophy parallelization. So JAX uses something called 3-fried counter as an algorithm for generating random numbers. So this 3-fried algorithm is much efficient than the Mersenne twister algorithm, which is used by NumPy. Basically, NumPy, mostly JAX is trying to mimic the NumPy most of the time. But one place where the JAX and NumPy library differs hugely is in the random number generation. NumPy uses Mersenne twister algorithm to generate random numbers, which is highly inefficient way of generating random numbers. But whereas JAX uses something called try counter algorithm, many of the seems to actually generate random numbers, which is much more efficient. Want to generate random number in JAX, you will have to first create a key. So I'm creating a key using random uniform, and created every time you want to generate a random numbers, you will have to split it. Then you have numbers using the new key. Once you use a key, which has to be discarded, no key will be used twice in JAX. JAX, a key will be used only once. Once you use a key, you will have to discard it. Every time you want a new random number, you have to split the old key and generate a new key to generate new random numbers. So under the hood, uses 3-fried counter algorithm for generation of super random numbers, which is much more efficient. So here I'm creating something called key. I'm creating a key, and I'm just printing out the key. So now I want to generate new key, new random numbers, and I'll have to split the key using split method and splitting it. So I'm getting old key and the new key. And then using the new key, I can generate a random number. So every time I need a new number, I'll have to split the old key. Or if I knew that I want 10 random numbers, I can generate a single key into 10 splits in the beginning itself. So this is how JAX number NumPy generation works. So we have seen a lot about JAX. So when should you use JAX is what we're going to see now. So if your code is using TPU as an accelerator, JAX works really well with GPUs. You can go for JAX. If you want to compute higher order gradients, then JAX makes it very easy to compute higher order gradients. And if speed is your end goal, then JAX for you. But when you use JAX, ML pipeline to build a prototype, then you can just stick to existing already know. And if the dynamically changing, then maybe recommended to use JAX. And if perform, then again it's not recommended. So what are the reference if you are interested in JAX or further? So I would highly recommend Nicholas Budivales, you from University of Waterloo. He has prepared a resource called Awesome JAX Resources. It's a GitHub repository which is very useful. There are other blogs like AI Summer School, RoboFlow blog. There are blogs from DeepMind. There are different blogs which are very interesting and very helpful. These are resources which I would recommend for you to use if you go further deep dive into JAX and get started with it. And come to the end of. If there are any questions in JAX, you can ask. And if there are any questions general you have with regards to data, how to get started, career related questions, either JAX or data science, all your questions, and we'll be taking it one by one and we'll get.
Thank you, ma'am, for the session. Like we have already the questions in the Q&A portal that we had. So over there, there are some couple of questions. That we answer.
Yeah. Question is execution time for JAX is 2.21 milliseconds. Then it means JAX is faster. So I'll come to your questions. I'll show you. So when you take some small dot product makes multiplication, so this. See, there are multiple answers to your question. The first thing is this code is running on CPU. In general, in CPU, you will be able to see that kind of a performance gain for huge number of functions as well, very huge function as well. You significant performance boost only when you use GPU and TPUs. But JAX is tailored to work well with accelerators. Another name for JAX is NumPy on accelerators. They call it because JAX works that well with GPU and TPUs. So you may not see this entire code is executed in CPU. So first reason why the NumPy is faster here is in CPU you not get that kind of a performance boost. Here the function in focus is just dot product. Not be able to see that kind of a performance boost when like it. When learning, you will write a complex function with lot and lots of dot product with multiple vectorized operations. That is when you will be able to start observing the performance difference. The third reason is whenever you run a function, what you actually see here is it is the time it takes. It is also the time which it takes to compile the function and all that. So the first whichever is given here is a time which it also takes to run the program compile the program, convert it into a byte level instruction. So whenever you focus on the execution time, you should always focus on the value which is after the plus minus. So that is what is the time which for the consecutive calls to the function. So first you will be comparing into bytecode and consecutive to calls to the function, is it faster or not. That is be more particular or more interested in. So these are the reasons it looks like NumPy is faster, but it's not actually the case because the whole code is written on CPU. So the significant performance improvement will come only when you start using the accelerators. So second thing is it's code which is just a single dot product. Again, when you start observing the performance boost only when you start using a function which contains huge number of dot products and it's multiplying, huge big matrices. Here the matrix is very simple. It's a small array of one-dimensional array of random numbers, so it's not a very complex matrix as well. So when you start having complex data frames, then you start seeing the performance. So yeah, this is the answer to your question. Okay. The first question by my Raja is answered. So if you want to build a data science career, I would you have two paths. You can get started with self-learning, or all the videos are available in YouTube. Every you want to know about data science is available for free in YouTube. So YouTube is your best study. You just put machine learning tutorials, you will find number of tutorials out there. So I'm just going to .com. I'm going to put example if deep learning is what I want to learn. A lot of deep messages coming up. Tutorials from MIT, one of the world's best universities. Tutorials from top, absolutely free of. You have so many free tutorials. These are tutorials which are more sufficient. You have tutorials from IIT. So everything can be studied free of cost from YouTube. Wonderful. So, but if you are willing, if you want to just tailored for you, or if you want something a bit more better than what is available free of cost, so try resources like Data Camp. It is not a paid free. It's a paid resource, but you can learn Python, everything in an interactive way. So very, very interactive teaching. So you will be more interested in this. Very, very small will be given. So it's a paid session. So you have to pay $6 for individuals, and $25 if you are a team. So you'll be if you are okay with paying $6, which is nothing but it's a 500 rupees. You can go for Data Camp. This is a very, very good resource. I'll show you why it is very interesting to use Data Camp. Give me a minute. I'll just log into my. I want to learn any course like understanding or introduction to Python, and can take this course into Python. So you can take chapters, every concept. This particular play button is a video, and you also have the corresponding exercise for you. So they'll give you a lot of clues here. To fill in the using these clues, you have to complete this assignment. So the videos which are here are just 2 minutes long, and you have multiple exercises to get started. So this is also a very good resource. Data Camp is my recommendations for getting the data science if you're particularly looking for courses. Other recommendation is Coursera. So in Coursera, a subscription called Business. So if you do not want the certification, you can log into Coursera. Any course, you can just order the course and you can start watching. There's a subscription Coursera Plus, which you have to pay around 32,000 rupees. And you can just, for per year, it is 32,000 rupees. For per month, it is around 6,000 to 7,000 rupees, which you can take any number of courses in Coursera. For that, if you just go for the subscription package of Coursera Plus, you can take any number of courses. You have everything: Google Cloud, TensorFlow, any topic you name, you have a corresponding course here. There is a particular deeplearning.ai, which is really helpful. Deep learning does not come under the Coursera certification, Coursera Plus subscription. So if you want to learn deep learning, you have to pay money outside. It will not come under the subscription. So under all, you have got nice courses. This is coming from Andrew NG, and this is a very, very good specialization. You have TensorFlow Developer Professional, Machine Learning for AI for Healthcare, NLP specialization, Deep Learning specialization, ML specialization also has come. So you can also get started with this specialization. Again, this is not free. And want free resources, then there is tutorials coming from DeepMind. DeepMind and the YouTube channel, you have got a lot of free tutorials on all subjects. Like you have free deep learning lecture series, free machine learning lecture series, MI, all machine learning concepts. You have free tutorial series taught by the world's #1 professors, and they have taught. These are some of the free resources which is available. Paid resources available as well. Data camp. These are some of the good options available based on your requirements and constraints. Courses in YouTube, or you can go for paid data camp. There are other provider service. There are many educational providers in data science. So yeah, with regards to courses, these are my recommendations. Some of these, if you want to join for data science, you can join data science. I think Google Developers Group. There's also something called TensorFlow User Group. There is one TensorFlow User Group, Hyderabad, out there. So you can join. As of now, FUG Hyderabad is something which is close to by events in TensorFlow. The groups are virtual, so you can choose any chapter. You can join Mysuru chapter if you want. You can join any of the TFUG chapters, where these are some of the communities which you can be part of. For TFUG Mysuru, which I lead, any of these communities, because all are state doesn't matter at all. So you can choose. These are some of the communities for machine learning. That you can also go for Google Developer or GDG groups in general. Google Developer also hosts a lot of machine learning talks. Some of the common recommended where you can get connected. Outside that, you can look for local communities in your city or in your closest neighboring cities. For Bangalore, if you take, there are AIML meetup groups. There are 7 meetup groups out there in Bangalore. They host a frequent meetings. Like if you take, you have something called Graph Data Science. They host Graph meetups. This Data Science Bangalore. There are many meetup groups which are there in Bangalore, which host data science related talks every weekend. There are talks based on the city. You'll have to filter out based on your city in meetup.com and find out the meetup groups in your city. So I'm just filtering out for Bangalore, and I'm showing you how to filter out. So you can take this is Bangalore. So in Bangalore, whatever city you want to put, you can just put it there, and you can just find out all the cities based on events. So December 31st, these are the events which are happening. January 1st, these are the events which are happening. You can just filter out based on machine learning, and then you will be able to find out the meetup groups in your area, and you can join that. So see, if you take Bangalore, Kubernetes Bangalore community there, then you also have data science series, DevOps meet, ML monthly meetup. There are so many communities in Bangalore. For every city, you can filter out based on by tag. It's not coming. I think maybe you should put Visakhapatnam or whatever. Visakhapatnam. So you can just groups around. So you have all the groups in here. So I think Visakhapatnam very less groups. Meetup is one way you can get connected. You can just filter out in the closest city. What Bangalore has got a lot of communities, but outside Bangalore, I think there are very few communities out there. You'll have to find out, or you can start your own community of your own, gather people, and start organizing events if there are not sufficient communities. From the Google ecosystem, I think GDG Cloud, and TensorFlow user groups are the communities from the Google ecosystem. If you are a woman, if you're a women in technology, not necessarily data science, women in technology, there is something called Women Tech Makers program, where they guide the women in technology from all fields like Flutter, Android, and data science and everything. So for the women in data science, you have something called WITS conference. In data science, you just have something called Women in Data Science Conference. There is a Women in Data Science chapter for Hyderabad. You can join the Women in Data Science. Hyderabad will have the conference, which is hosted in February, I think. So you can join that conference. It will be an offline conference. And so the closest city for you will be. And you also have WITS Bangalore. And I can be sharing the dates because we are organizing for WITS Bangalore. It is an with Usha, and she'll be able to circulate it to you. But if you want to attend the offline conference, the closest city for you, which is hosting the in February, January, they are the first people to. Every year they host in February or Jan. They might be hosting in Jan or Feb. I can share it to you. You can go at mostly a minimal fee of 500 rupees or something in the event. And WITS Bangalore, I am Bangalore, and that will be generally 3,000 rupees. Generally, every year they charge around 3,000 rupees to 3,500 rupees as the fees for attending. I'll circulate the links with Usha, and she'll be able to share it with you. So you can attend these conferences where you can meet a lot of data scientists across India who have accomplished a lot. They'll be invited as a, so it is a good point for networking. If you want to attend free event, then I'll be organizing a data-thon, which is free of cost. It's a virtual event, so you can be anywhere in the world, you can attend it. Just finalizing the date free event, and once the dates are finalized, I'll circulate it to Usha, and you can join that free event which we are organizing. Outside that, most of the events in WITS are paid. 3,500 rupees because it's hosted, and the whole conference. So I think the charge, the fees is for Hyderabad, it will be very less only. It's mostly for Hyderabad. So the closest city also will find that. And I think that added in Amazon and So I think this year also they'll. Yeah, this is with regards to the women in data science. PyTorch TensorFlow is better. If you want, JAX is better. Otherwise, PyTorch and TensorFlow are equally good. You cannot say PyTorch is better than TensorFlow or TensorFlow is better than PyTorch. Both are equally good. When you go for production systems, that is, allowing your models and all, got an edge because you have a lot more cloud platforms coming from Google's, which is a lot more. The ecosystem is bigger, so TensorFlow has some advantage when you go for production level systems. But generally, people go PyTorch because it's very high. So otherwise, speed or no speed, it's JAX. If you're not bothered about speed, then TensorFlow. Basics of ML, but I want to learn all scratch. Can you tell me how to go for ML? So weak in mathematics, so please tell me about this. So if you want to learn the mathematics of machine learning, then what I would recommend is getting started with probability and statistics tutorials, and kind of what level of engagement you, if you can handle advanced tougher math. One of the recommendations which I have is uh, probability and statistics is very very important. So to learn linear algebra, then one of the way you can learn is using Khan Academy. So Khan Academy, it is a lot of videos, but they have a free linear algebra course which you can use for learning linear algebra. Linear algebra is very very, these are free videos. Outside this, there are other free videos as well for linear algebra, like Blue. I think course from. So the three blue, one brown. So he uses a lot of animations for teaching linear algebra. He also has tutorials for other mathematics as well. Tutorials he has got, calculus he has got. So he uses a lot of animations. I'm just playing one of his videos. You'll see he uses a lot of just but if you just see the way he explains, he uses a lot of animations like this. So it's very interesting for people even without mathematics interest. They'll be easily able to understand all these things. So this is three blue brown. This is a channel name which you can use for learning linear algebra. He also has a calculus tutorials as well. Outside this, a quick refresher from Google itself is linear algebra here, where they teach all the important concepts which you ever want to know in linear algebra is taught here. So that is also one recommendation. Quickly, you can learn all the important linear algebra full course in free code cap. Which I would recommend. These are free resources and so Khan Academy or three blue, one brown, TensorFlow introduction, and these are my recommendations for linear algebra. This is if you want to learn mathematics in a. If you are okay in learning, investing some, if you can handle complex level mathematics. You want something which is complex. Easy means you go. Something complex, you go for MIT's. This is a huge number. Long, and you have a lot of videos here. This is the right way to learn linear algebra, provided you can handle a little bit of in learning. Easy. It will be little, you'll have to focus a lot, you'll have to watch it multiple times. But if you can have complexities, then this is the best resource you should go for. Gil linear algebra series. So this with regards to this thing with regards to linear algebra. For probability and statistics as well, MIT has got uh, probability. MIT has got probability series. MIT also has got statistics, introduction to statistics. But if you do not want this kind of a complexity, if you want something very, very easy, give you some free resources. His name is, I forgot his name, but he is a very StatQuest. So StatQuest is very easy if you want. You can't handle MIT. You want something easy to learn, then I would statistics and StatQuest as well. So you can go to StatQuest if you can't handle that kind of a complexity which MIT level professor is teaching. So based on what is style of learning, whether you want to learn mathematics in an easy way with a lot of animations and animations of few channels. If you want to learn mathematics in a very tough way, then I have also given you some recommendations for lecture. Outside this, if you want to learn a course and you want to get some proof that you have learned a course, you can also go for Coursera. So if you have some mathematics for machine learning specialization specifically, one specialization is released from the deep learning.ai itself. Outside other universities in UK where you've got mathematics for data science specialization, multiple specializations. You can go for Coursera just in case if you want to, you just take a course and stop with it, but you want a proof that you have taken a course from a very good university, top university, then case you can Coursera, choose the best universities. If you say there are multiple universities offering mathematics for data science, you can just put mathematics for data science, multiple university options. You can just you have data science from Duke Universities, Imperial College London, from University of Colorado, multiple languages, and this Duke University is absolutely free of course. You don't have to pay money also. So there are the 4 free courses available for mathematics for data science. Only if you want a proof that you have learned some course and to put it in your resume and stuff, then you can go for Coursera as well. These are the options for learning mathematics of data science based on your requirement on what is your interest and what is the area you start. I think these are the options available for you. Chiragawa. As JAX, many companies use for Python. JAX is an upcoming framework, and JAX doesn't support many third-party libraries. So there are certain. I have shown you only basics. As you go higher and higher, JAX gets very complicated. There are so many constraints on how you should write programming in JAX. Those constraints are very, very difficult. Unless and until a person is a very strong programmer, they'll really struggle a lot in programming in JAX. So JAX is not as easy as it sounds. When you start writing the end-to-end pipelines, it's very complex. And it's also support for the third-party libraries also is very minimal. And it's an upcoming framework. Few people are using it. And if you're getting stuck somewhere, then you're stuck forever. There are not many people to help you out as well. So the ecosystem is very small as well. That's why many companies are not preferring JAX as long as they really require speed. Even in they really require speed, they prefer NumPy because the NumPy is relatively a bigger ecosystem. So some of the reasons behind it. But the future of machine learning research might be JAX. Maybe there will be a lot more adoption coming up in future, but at this moment, there's not much of an adoption. See, NumPy is a just-in-time compiler, which you can pair up. NumPy is a just-in-time compiler. You can pair it up with NumPy, and you can do just-in-time compilation. But NumPy is a compiler. That's it. But it is not a replacement for JAX as well. So JAX has other additional facilities outside the just-in-time compilation as well. NumPy is a just-in-time compiler. JAX is a programming. Deep learning, how should I get further proceed? Once you finish your machine learning course, real world projects. So the project some real world use cases. For example, using deep learning. If you finish deep learning, image classification there, one of the computer vision. So you take some real world, don't put your usual projects like Titanic classification, take some real world healthcare or retail or manufacturing, open source data sets available. Try to do some project which is something different from others. Your project is the main criteria whether your resume will get selected or not. Have a strong GitHub profile. Do as many projects as possible. Develop a strong GitHub profile. The first thing which a recruiter looks at in your profile during hiring process is GitHub. So have a very profile. Have a very media profile as well. And projects and trying to get into internship. If you're not able to get into best internship in the beginning, whatever internship comes your way, there are many opportunities for unpaid internships. So please try for internships which, but if you're not getting paid internships, at least try to get into some unpaid internships and try to get some experience on board. And once you get a sufficient experience, then you can, or go for, you can demand a lot. But try to and try to build as many good projects with end-to-end machine learning pipelines. Try to learn as well. Try to get some of the cloud, whatever cloud certifications, whatever you understand how machine learning models are deployed and how to scale up your machine learning models. There are other things around machine learning also. You can try to get some beginner level understanding of these things as well, so that your profile stands out different from. Most important thing, which will be a crucial determinant, will be your projects. Try to build as many unique projects as possible. From in data science, trying to learn TensorFlow. Would learning JAX is just some new framework on the block. If you're purely trying to get an internship or getting into a new job, learning JAX may not help much, because JAX in the first place, what people in the research labs are doing, unless and until you're trying for a job in DeepMind or Google Research or IBM Research or all these research labs. If you're not trying for a job in these research labs, then JAX will not help in any way. It's just an upcoming framework. We don't know what the future of JAX will be. In future, many people might start adopting it or something like that, but at this point of time, it's predominantly used in DeepMind and other research labs. So learning JAX may not help you in getting a job for sure. So TensorFlow, Python is what will get you a job. If you're learning TensorFlow, become very strong in it and try to get a job there. You will be able to get much more openings for TensorFlow is there. Learning JAX will definitely not help you in JAX. Research, job search for sure. I'll be available anytime you want me to take a sessions. I'll be available to give you more such sessions as well in future. So definitely yes. So the best for doing data is first start with a course. Either you can use resources which I've listed earlier or paid resources. Choose whatever is your learning curriculum, learning style. If you feel both the free and paid resources, you don't like self-study at all, if you're very particular about it, then you go for live instructor-led study. There are many centers, data science centers right now in every city it is there. You can go for instructor-led series. That will help you better because you have a mentor as well. If you're okay with self-study, you can learn it on your own. But if you feel you're not okay with self-studying, you want to learn it in some center only, then that is also a good option. Based on what is your level of studying, first finish learning the concepts. After you finish learning the concepts, try to do a portfolio of projects. Take some real-world use cases. Kaggle has got a huge open source repository of more than 100K data sets. So you can choose some data sets, either if you like healthcare, or choose what are the data sets. So if you take computer vision data sets in healthcare, you have like breast cancer detection, you have skin cancer detection. So many medical use cases are there. You can take some of the use cases, open source data sets, and try to build an end-to-end pipeline. Try to create an app and or web application or mobile application for some of the use cases. Then you can put that as your portfolio. Third thing is come out, give a lot of community talks in your communities, GDG Vizag, if you're in Vizag. Reach out to the community organizer, ask for opportunity to speak at the event. Build your strong public speaking skills. Start writing blogs. Use Medium. There is also towards data science, analytics Vidya, Analytics India magazine. Start contributing to blogs. Reach out to the community organizers, because right now there's again road to certification. There are many certification programs, many launched by Google itself as a part of the resources for that particular technical. Flutter campaign is happening from January. So the organizers will have the curated resources. Go reach out to learn more about it. So whatever is you can get started with. And the second thing is try to get into internships. Apply for get into some internships or the other. This roadmap for data science before try to do as much research for the about the you can contribute to the company. Why should they hire you? So that is a question which you need to ask yourself. What are the relevant skills which you have, which the company can get by they hire you? That is a homework which you need to do and develop skills accordingly. It could be visualization skills or storytelling skills or whatever skills which the company requires. By the end of the day, the company is going to hire you because they have a business problem where you can add value and they can get money out of it. So you should be, if you're trying to work for another company, you should make yourself you should develop all the skill sets which might be relevant for the company. So that is the research. Find out all the startups which are working in data science. If you're interested in computer vision, find out what are the startups which are working in computer vision. Find out what are the relevant skills and try to work on those skills and build those skills and try to have relevant projects. Then the company might, if they see a relevant match, they'll call you for the do as much networking as possible. Find out all the founders, send them a request jobs. 99 not be bogged down by rejection because same set of skills. So rejection is very normal. People, for sure, I know even the best of candidates they have been rejected so many times. So you should not be getting bogged down by rejection because the competition is very high. For a single, some 900 applications are coming. So the competition is very high. And so you should be using heart. You should keep trying. That is the option which is left at the moment. Otherwise, you will have to start your own company. So you should not be bogged down by the campus placement is the best always. Outside the campus placements, it's a lot of struggle always. You'll have to not lose hope, keep trying, keep working hard, keep improving your skills. Reach out to your mentor, find out a mentor who is accessible, who is able to answer your queries and available for you. So not everyone will have the free time. So find out somebody who is close to you and who is accessible to you and who has bandwidth to assist and guide you. Ask them to review your resume, ask them to understand, just check with them why the things are going wrong, get feedback and try to work on the feedback. So this is keeps going on and on. So don't get bogged down by rejection failures. Data is important for any career. See, if you take data science, you have got high level libraries like TensorFlow, Python, or JAX, and all. But sometimes, business solutions is not very easy. It's not like you take some high level framework and you build an end to end model. Your problem will not get solved in real world. In real world, or the big Fortune company, they can sometimes use the existing high-level frameworks, but sometimes they have to build things from scratch. They have to build things from the scratch. See, they may not be able to. I recently went to a startup where they were using NumPy as the code base for their entire machine learning data science pipeline as well. So not many times you can use existing high level libraries. Sometimes you will have to build things from the scratch. You cannot use TensorFlow. You cannot. There will be situations where you cannot use Python. So there will be situations where you cannot use the existing high level libraries. That time you will have to build things from the scratch. To build something from the scratch, anything related to programming, you require data structures. Data structure is the fundamental building block of any programming language. So you data structures, that is very important. Even if you want to become a data scientist or any IT related job, I think if it's technical coding related job, then data structures are very, very important. You need to understand the fundamental building blocks of a programming language, which is data structure. So it's important. How do you learn about it? You have several websites, Lead Code. You have several websites to learn data science. There are some courses in Udemy as well, and so you can pick up the courses from all these places, and you can start practicing. And there is also something called algorithmia or something for algo science or something. I forgot the name. So they also have some subscription based tutorials for learning data science. You've got free YouTube tutorials as well, many million blogs. Lead Code is also a good resource. There are multiple providers, service providers for teaching you basic programming, data structures, and algorithms. So you can choose the one which works better for you. But data structures are important. How to stay consistent while learning? Choose the right level of course, whatever course style and what works for you. Figure out and choose something which works for you. Staying consistent is basically to build this practice, like working 30 minutes every day is some kind of a relief for yourself every day. 5 to even if it is 15 minutes, try to develop your own career. 15 minutes or 35 minutes of you have, and every day take to first structures like what is tags, queues, LinkedIn. You understand. Then under stacks, under 400, 500 problems every day, try to solve 2 of them or at least one of them in the beginning. 20 minutes, 30 minutes every day is enough. But build a religious schedule. Whatever, first find out the resource which works for you. Something called coding blocks. There are many resources out there. So choose the resource which you. Lead Code is used by a lot of people. I've already started the process of learning and applying skills. Presently, I have a decent knowledge of Python, SQL, and data libraries. I'm confused whether I should learn more or proceed learning new skills. It's not necessary you should know every particular framework out there. Even if you learn whatever you have learned right now is more sufficient, get started with building some real world projects and build a strong portfolio. Even if you know 2-3 frameworks, knowing it very thoroughly and being very is more than sufficient. Instead of learning anything, you learn some 3-4 things and be is what is my recommendations. Self-learning motivation is it comes for self-learning motivation. It depends on, you have to assess your life as a whole. People, if you feel you're not able, you're procrastinating a lot in life, you're not able to stick to the guidelines, or you're not able to motivate it in life, there are other factors in life which is disturbing you, which is not letting you do things which you want. So you will have to analyze your life internally from a psychological point of view why it is going wrong. Motivation is directly linked to your other habits, like are you eating healthy foods, are you in the morning, or what is the schedule in general. It is linked to other factors, so you will have to start analyzing your life from the other perspectives and find, first figure out if you really want to learn data science because you're interested in it, or is you're interested in data science because everyone around you is learning data science. If you're just learning data science because everyone around you is learning data science, you will not have that kind of a deep motivation. So first you ask the questions, why you are learning it. What is the goal of learning data science? Is it really because you're passionate about data science, or you just want to learn because everyone is learning? Told data science is the sexiest job, and data scientists are earning a lot of money, and that is why you want to learn. So find out the ultimate goals or reasons why you are even getting started with data science. That is important. People don't ask that question. So only then you will figure out your real motivations. Once you're clear with your real motivations or reasoning behind why you do a certain thing, I think everything else will fall into place. Learn data science just for learning money. I don't think data scientists are the only people who are earning high. I think anybody, even if you're a Flutter developer or even if you're an Android developer, if you're given in any skill set, if you're very, very strong, you can earn money. I know a lot of front end developers, back end developers earning plenty of money as just freelancers. Most of the Android developers I know have just quit their high performing jobs. I know a lot of people who have just quit jobs in Google, Microsoft, and they're just doing freelancing in Android Flutter because it's a lot of money. So I don't think money should be a reason on to learn data science, because other jobs are equally paying well. Any job, if you are very strong, you will get paid well. So identify the reason why you want to learn data science first place. What is it about data science which really interests you? These are the questions, right kind of questions you should ask in the beginning itself. Otherwise, you spend 3 to 6 months learning it, and then you realize data science is not something which is for you. Then it's a lot of time waste. So ask these questions in the beginning. Do a self introspection. When you have very strong motivations or reasons to learn, I think it's very easy to maintain a self discipline and regulations as well. And there are other factors you need to focus in life as well, having good healthy food, exercising daily, because these are all factors which will play a huge role in concentration. So if you want to concentrate really well, you have to eat a lot of healthy food. And if you want to, if you're already working and you want to maintain a schedule, then you have to complete your work, whatever, as a part of your full-time job, whatever you're doing, you have to complete it faster, so that you can allot time in something extra, like it could be data science or anything. So for that, you need to be more productive at your full-time job. You'll have to do a lot of things. It depends on where you are in life, whether you're an employee or whatever it is. As you can find, definitely it's not, even if it's 20-35 minutes, just fix that goal. And learning has to be, you have to find, like you learn a concept once and then it will stay in your memory. You have to learn it again and again. So it's periodic and consistent over a memory as well. And it's just not, you have to apply those concepts as well. Only then the true learning comes. So the answer to the question is very, very interlinked with a lot of factors. So I would suggest do a personal introspection, which will give you the right kind of guide for building your own self-motivation regime. Okay, we'll take last two questions, one by Pratusha and Surya Challa. We'll just take last two questions. The question by Surya is not feeling overwhelmed by everything while starting out. One of the big mistakes which people do is they'll take 10, for example, if I want to learn deep learning, doing this, they take 10 courses in deep, enroll themselves in Udemy, they enroll AI certifications, they enroll themselves in that. So you don't have to take 10 different courses. One course, just choose one course. That, and just stick to Jovian.ai course providers who are very, very good. And just choose one course, use that religiously over a while choosing. Before you choose a course, do a lot of research work and try to find out what really works out. Some different instructors have different way of teaching which might work for different set of people. So what is your style of learning is something which you, and for your style of learning, which kind of instructor is better suited, whether you learning too much of theory and then coming to programming, or you like theory programming, or you like this bottom approach of starting with and then coming back to learning theory. So the courses are very varied in nature. You will have to understand what is your style of learning and choose the best course out of the 10 possible courses available there. Once you choose the best course, just stick to one course, read it over and over and again, and just don't overwhelmed by so many things. It's not necessary. Nobody will ask you how many courses you do in deep learning. The instructor is only going to test you on the concept. So just choose one instructor, and the interviewer is not even worried which course you took. He is interested in knowing whether you know the concept or not. So choose one course, religiously learn that one single course. While before choosing the course, do a lot of research and choose the best one course which works out for you, your style of learning. And once you decide on that, just read that religiously and then start applying those concepts. People, this if you just stick to these basic things, that will, I think, you will avoid getting the overwhelming. And you don't have to learn too many things. You don't have to know, you don't have to know everything out in data science. If you can just focus on NLP alone, be a top expert in NLP, that's more than enough. There are NLP jobs out there. Or you can just vision and be a top expert in that, or you can just choose time series alone, or you can choose one subsect of data science and be a top specialist on it. You'll end up getting a very good job as well. So you don't have to know everything out there in AI. So I think this is my recommendation for not getting overwhelmed. And see, when you take data science projects, there are a lot of repositories called awesome GitHub repositories. For example, if you take awesome NLP projects, you can just put awesome libraries, awesome NLP. So you have top GitHub NLP projects here. So if you are interested in natural language processing in NLP, these are some top GitHub repositories. The entire repository project, full to full paraphrase, identification, document similarity, the entire end-to-end project is available here. So you can, whatever domain you are interested in, you go to GitHub and search top GitHub projects in NLP or top GitHub projects in computer vision. Your reference point. You take this project, document similarity. What is the real world use case, of where in real world they use this document similarity, and you understand what kind of data set this current project has used and how they have done the end-to-end workflow. Understand the existing project so that you will get inspiration for new ideas. So while you're starting existing top projects, top 50 projects in each project, do an analysis like what are the data, what is this project, how is it being used in which domain they are using it. Do an analysis. It will give you more interesting ideas for your do something which is the existing project is not doing. That could be a new project, or yes, when you start understanding the existing. I just put a random search top 10 NLP. And you'll find a lot of links if you just search for the existing NLP project, is any repository you want to. So there's awesome deep learning also, awesome. Maybe a lot of cool projects out there which you can just go. So you have so you can just go through all these projects so that you'll get new ideas for getting started. You have some reference point to get started. My recommendation for getting started. This is not just for computer vision. You have for any module you can just do a GitHub search and find all the existing top 50 projects in computer vision or NL time series or deep learning. Go through each and every project, see what data set they've used, what programming framework they've used, how is it really helpful in real world. That is, and then you will get you. That is how you build inspiration for new projects. Or you can just try to replicate somebody has done in Python. That's a flow, and you can improve your programming skills that way also. So these are some of my recommendations. And Kaggle has got huge repository of data sets. Kaggle has got 100,000 data sets. You just you go to sets, you have 100,000 data sets in Kaggle. Any field you want data sets, you can. Now I see. Okay, climate, I want all the data sets related. There are so many climate data sets which are coming. There are so many agriculture survey of African farmers, so many climate data sets. Okay, now just go for yeah, I want all the data sets in energy prediction specifically. Energy consumption, I want all the data sets related to energy consumption. And just hardly there are so many open source data sets which you can use for as well. So Kaggle 100,000 data sets you can use. Indian government has so many repositories for those data sets where you can get problems which Indian government is facing and you can solve them as well. So if you take many countries, states, India which has got flood problems, you can do automatic segmentation using area imagery. That is a very interesting use. There are many wind in India. Wind energy is being wind generation. Government is collecting data for every single thing. Every state is maintaining the record. You can the interesting factor in the crime rates using data science. Live traffic prediction. Every city has got traffic data, right? Lives you can do an analysis of the live traffic data. Every city has surrounded by Vizag, a lot of forest and a lot of things. There are a lot of animals in the forest, a lot of birds using machine learning. There's so many use cases out there. Indian government has got a lot of open source data sets as well. You can take up some of the projects, can form teams of 4 or 5. If you do it alone, you overwhelmed. You can form a team of 4 or 5 people and get started with the project. In fact, I think it's Hyderabad. I think they had some related hackathon as well. I think government was conducting that hackathon. There are many hackathons where disease prediction in crops. How can you estimate how much of a crop is going to get generated every year? Flood prediction. There are so many use cases in agriculture itself. So you will find plenty of use cases. If you just look around, everything in the world right now is consumed by AI. Day-to-day activities, everything. So you take our personal life also. We are using this Fitbit and all these devices, right? You can use to monitor the sleep states of a human being, and that personal data is used for a lot of analysis. You can just take, like, there are open source data sets which contain this Fitbit data. You can use that project as well. So any and everything related to us as data, and that data can be converted into a personal project. So there's no shortage of data sets in a country like India, and plenty of available. You just have to look around and you'll find multiple data sets. And for inspiration, existing, I told you how to go to GitHub repository and existing projects. So you can see, for example, found out the climate data in your state, and now you want to find the project which is available already end to end, so which for you to search serve as an inspiration. You can just go and do climate prediction, or what is that, rainfall prediction. So for example, rainfall prediction, machine learning, GitHub. Just do a search like this, you will find all the GitHub rainfall prediction using machine learning. So which is available in your country if you're interested in. Once you find out the data set, understand, then go and search in GitHub repository into projects of similar data. You can use that approach. You can apply for your particular state, and so these are ways how you can build. I'm saying because these are easier for everyone. Plenty of other use cases as well. So do an analysis. You will come across multiple. Yeah, I think.
Thanks, Usha. Thanks so much. I think we'll conclude here actually. Yeah, go on.
Yeah, Usha, for hosting me and GDG Vaisak team. It's been my pleasure to do this for 2022 with the Usha session. And yeah, Usha is somebody whom I really look up to. Her resilience and perseverance is unmatched, especially during the death, when she had a very personal situation and she was uh, and I was so surprised how she not gave up even during that personal situation, and she still had organized the deaf fest story for me, which I've come across in the end. Resilience and perseverance, I really admire. It's my pleasure and honor to do the last CDG Vizag and hosted by. Thank you so much for the opportunity. Hope you can always reach out to me for any questions over LinkedIn or Twitter.
Yeah, thank you so much, ma'am, for speaking to the community and taking your time for us to answer some of the resounding questions that we had from the audience side. We had from long back, and you were answering all that patiently. I hope it was an informative session to all the audience, and definitely we all found it worthy to join and participate in today's session. So we are grateful for the time you have taken for us and sharing your thoughts and experiences. Thank you so much, ma'am.
Yeah, and I want to say thanks so much, Usha, for coming. Actually, I know you have been extremely busy and all that, but the kind of wisdom you have shared and the links and all that, the detail that you went for each question, really, I really appreciate. It shows your passion, uh, especially the use cases and all that. We have had conversations before where even she has been part of my podcast also, and she was explaining in detail about a few use cases, and I'm really happy that you took time to dig into the session. Actually lasted only 40 minutes, but the questions actually it took the remaining time, and I'm so happy that those kind of questions came up, and I'm happy that you went into such detail in showing us about going through actually in each of them. So thanks so much, Usha. Also, I would like to thank our team. I wanted to share that many of our team members, they are going through exams right now, sem exams. So we had even team wise, we did not have that much strength because sem exams are going on. But despite that, because we wanted it to be a part of DevFest, this particular talk, so we arranged and people came, and I should thank Prasida for taking that interest, and despite her sem exams and all, they've been balancing. So it shows the kind of interest that my community has for this subject, and we will definitely touch base actually. We would invite you over maybe sometime soon, perhaps for IWD, hopefully, so that we can have more engagement with you in person as well. Thanks so much, Usha. Cannot be more happy that I have hosted you at the end of this year. On that note, yeah, thank you and good night. Bye bye.
Yeah, Happy New Year, everyone. Bye bye.
Bye, and Happy New Year to you too.